Hello and welcome back. Today we're going to be talking about a really important formula that's involved in linear relationships. Okay, we're going to be using some of the skills that we've learned over the past couple of lessons, mainly the idea of gradient and how we can apply this to make a general formula that can help us find a line given just a point and just a gradient. Okay, I'm going to split this video up into two parts where we talk about then finding the equation of a line that goes between 2 points on your Cartesian plane, but that'll come in just a moment. Okay, we're going to learn today about what's known as the point gradient formula. Okay, it's this thing here, this point gradient formula. Now, why is it called the point gradient formula or point gradient form? It's because what it uses is a point on your Cartesian plane, so x1, y1, and this specific point because we have the subscript 1s there, so it's telling us it is a point, and we use a gradient, m. Okay, that's why we call it the point gradient formula. And what this allows us to do is it allows us to get the equation for any line if we're given a point or if we're given the gradient, and if we're given the gradient, my apologies. Okay, so I'm going to show you where this thing comes from, but the first thing that we need to do is we just need to understand a little bit in terms of visually what's going on. Okay, so you'll notice here that I have a specific point and then I have a general point here. I have an x and a y. So this is x1, y1, so that's our specific point that we're given. And then I have an x and a y. Now this x and y is any point that I want on my Cartesian plane. I can move it anywhere that I like. It doesn't have to be placed over here. I'm just going to use that just for the sake of argument. Okay, so I'm going to show you how we actually derive this formula. The first thing that we need to do is we need to think about the equation of this line in terms of the gradient. Okay, so we have a rise and we have a run. So just remember that. We essentially have m equals rise over run. It's quite a simple derivation here. Okay, so let me just focus up the video so you can see what's going on. Alright, so m equals rise over run. Rise is our vertical component, run is our horizontal component. So let's have a look at how we actually do that now. Alright, here's my rise, and you'll notice my rise is just the distance from this point to this point, vertically. So that's equal to whatever my y point is, my general y point, and I subtract off the y1, so y minus y1. Remember, I'm keeping things general here because I want to make a rule for all of my equations. Okay? And then vice versa for my run, well, that's going to be the distance from here to here, okay, running along here. That's going to be my run. All right, so I have x minus x1. So here's my rise and here's my run. Now, when we substitute those two values into our formula, we have m equals y minus y1 over x minus x1. Now, this is already looking pretty good, all right? It's pretty close to what we have up here. So what we're going to do is we're just going to remove the denominator of this fraction over to the other side, okay? So I'm going to take the whole x minus x1 and I'm going to multiply it over to the other side because this is a divide, okay? So I have x minus x1 out the front of m equals y minus y1. And that's actually all we have to do. We've actually already gotten the equation that we have up here just after a little bit of rejigging. So if I swap the sides, so y minus y1 equals, and instead of having the m out the back, I'm going to put it out the front because we can multiply in any order. So I now have m outside of x minus x1. And that's how we achieve the point gradient formula. So now what we're going to do, now that we've derived it, is we're going to have a little bit of a look about how we actually use this to find the equation of the line given a point and given a gradient. Okay, let's have a little bit of a look now. Okay, so this question is asking us to find the equation of a line in general form that passes through the point 2, 5 and has gradient 3. So let's break this down a little bit. So it's the equation of a line in general form. Okay, so that means we have everything over one side that passes through the point 2, 5. Well, we have our point now, and it has a gradient 3. Well, now we have our gradient and our point. So when you see questions like this, that should be your hint to use the point gradient formula. Okay, right? And so take your point outside here, and I'll just show you why I do this. I still do this just to make sure that I'm doing everything correctly. And take your gradient out. I'll write m equals 3. Now what I'm going to do is I'm going to write down my formula. Y minus y1 equals m out the front of x minus x1. Okay? So now I'm going to work my way through this formula. I'm given the gradient, I'm given the point. Okay, so x1 and y1. I always label it just to make sure that I'm being consistent and I don't make any silly errors when I substitute in. Okay, so my y1 is the 5 point because that's my y coordinate. So y minus 5, just substituting in now, equals m, my gradient, 3. Okay, just putting that in, outside of x minus, instead of the x1 here, I replace it with a 2. Now, it asks me to write this equation in general form. So what I'm going to do is I'm going to expand everything out and move everything to one side. So I'm going to go y minus 5 equals, and I'm going to expand out these brackets, 3x minus 6. All right, so 3 times x and 3 times negative 2 will give me minus 6. All right, and remember, with the general form, I want x to be positive and I want x to be first. So I'm going to move everything to the same side as the x. Okay, so I'm going to move this minus 5 and add it. So y equals 3x minus 5 plus 5 will give me the minus 1 here. Okay, you'll notice that we've actually got this in gradient intercept form, just for your own reference, because we've got the gradient 3 and where it intercepts the y-axis, but we haven't got it in general form. So I'm going to take the last little bit, the y over. Instead of a plus y, it's going to become a negative y. And I'm going to put that in the middle. So 0 equals 3x minus y minus 1. Just remember, we're trying to make it look like this. Ax plus by plus c equals 0, where a, b, and c are just numbers. Okay? They can be positive or negative. The only thing that has to be positive is a number out the front of the 3. Okay? So, that's the first question. So you notice we now have the equation of a line that goes through this point and has this gradient. Okay? And that's a unique line. So let's have another go at another question. Okay, so it says write in general form the equation of a line that has a gradient of negative 1 over 3 and passes through minus 3, 4. So again, I go through and I just highlight everything that it wants me to do. So general form, it wants to find the equation, it has a gradient of minus 1 over 3, and it passes through this point of minus 3, 4. Alright, so just like last time, we have a point, we have a gradient, so we're going to use the point gradient formula. Okay, so we end up with, let's write down our point, minus 3 and 4. Okay, and we're going to label that x1, y1. All right, and we have our gradient, m equals minus 1 over 3. So now we're going to go straight to substituting in. I always write the formula out just so I don't forget it. Y minus y1 equals m outside of x minus x1. This is quite possibly one of the most important formulas that you will need in your future careers as mathematicians, particularly when you get into the topic of calculus. So that's why I put such emphasis on making sure that we memorize this formula, okay? So let's keep going. We're going to substitute all of the points in, but we have to be a little bit careful when we have a negative involved. Okay, so we have y minus, instead of y1, I'm going to put minus 4 equals our gradient. So now we have negative 1 over 3 out front of x minus, and I'm just going to, just in brackets for you, just put a brackets around the minus 3 that we sub in, just because I'm going to pick up a common mistake that I see students make all the time. When I have a negative times a negative, that will actually make it a positive. Be very, very, very careful when you're doing this, okay? All right, so we have y minus 4 is equal to minus 1 over 3, and we're just going to tidy this up to give us x plus 3. Always work inside of your brackets first before you do anything else, and just tidy up from line to line, okay? So now you have a couple of options, okay? You can get rid of the fraction earlier on if you'd like, because remember we are going for general form, and you can multiply this denominator over to the other side, okay? I don't mind how you do it. I'm going to show you how you do it without multiplying the fraction over the other side, okay? So here's what we're going to do. We're going to expand, so y minus 4 equals, and this will be minus 1 over 3x, so minus 1 over 3 x, right? And then the minus 1/3 times positive 3 will give you minus, and a third times 3 will give you 1. Okay? Now just remember, what you want to do with this particular case is that you want to make sure that you have no fractions whatsoever throughout your equation when you're going for general form. So we're going to multiply everything through by 3. And when I say everything, I genuinely mean everything. So we're going to multiply this by 3, which means this also gets multiplied by 3, and this by 3, and this by 3. Okay? So just being very, very careful. I'm going to show you the other method in just a moment so you can evaluate for yourself which one you find faster. Okay? They're the exact same thing, just in different order. So now I have 3y minus 12 is equal to minus, instead of the minus 1x, I'm just going to put minus x because we've cancelled. That was the whole point of multiplying through by 3. And then minus 3 here. To write it in general form, we need x to be positive. So I'm going to move the x over, okay, and make it positive. So I have x plus 3y minus 12 equals minus 3. And we're not quite there yet. We need that to be equal to 0. Okay, so x plus 3y. I'm going to take minus 3 and add it. All right, minus 12 plus 3 will give you minus 9. So that's the equation of your line. Alternatively, okay, what you could do is in this step, you could take this 3 and multiply it up to the entire other side of the equation. There's nothing stopping you from doing that, okay? And I'll just show you why we might do that, okay? So essentially, we could go down the path of 3 outside of y minus 4 is equal to minus 1 outside of x plus 3. Okay, so instead of going down this path, we're going to go down this path now. Now we're just going to expand the brackets on both sides. So 3 times y and 3 times minus 4 is 3y minus 12, which is equal to, and then minus 1 times x and times positive 3, which is minus x minus 3. And you'll notice that we've actually ended up at this step here, and you might find that that's a little bit less work for you. It's up to you completely, okay? So it's just sort of figuring out which path you want to go down. It is completely and totally up to you. Okay, so that's all we're going to do in this video. In the next video, I'm going to come back and I'm going to show you how to find the equation of a line that goes through 2 points. And we're going to have a little bit of a look at that. Okay, all right, but that is it for now. Okay, thank you very much. I'll see you soon.